Hi, and welcome back to Gaffey's Grinds. In a previous lesson, we looked at how we can take two different elements, for example, iron plus sulfur. And you'll remember that iron was like a gray metal powder, and the sulfur was a yellow non-metal powder. And these two things, we mix them together, add some heat, and you get a chemical reaction to make a new substance. And that new substance is called iron sulfide. So quick reminder then that these two things here, these are pure elements, so only made of one type of atom. So this is an element. This here is also an element. This here, the product in this case is not an element anymore. It's a combination of elements. And we call combinations of elements, we call them compounds. So iron sulfide is a compound. Now, we also know that if we go to the periodic table, we can find the chemical symbol for the elements. We call them Fe is the symbol for iron, and capital S is the symbol for sulfur. Now, we won't be able to find the symbol for iron sulfide on the periodic table because it's not an element, but it still has a chemical symbol. So in a second, we're going to look at the chemical symbols for some compounds and see what those mean. Before that, though, let's take another example of a compound. Let's say we have substance carbon monoxide. This here is a compound. We're going to learn about how to write chemical formulas. Compounds. So these here are what we call chemical symbols. Just represent one element. This is a symbol and this is a symbol. But this thing over here is going to have something called a chemical formula. All right, let's go back to carbon monoxide. Let's look at the name for a second. I'm going to highlight what's in here. So first of all, I see this word carbon. Okay, now what that tells me is that there has to be the element carbon in this substance. I also see oxide, which gives me a clue that another element that's in here is oxygen. We learned last year where the "ide" comes from. It's just that we changed the name of the second element. We dropped the "igen" at the end. So instead of being oxygen, it changes to oxide in a compound. The last piece of information that's here is this word here, mon. Now, this word mon means one. So in chemistry, we use mon to mean one. So what does this actually mean, this name here? What does this actually tell us? Well, this name tells us that we have one carbon atom, and then this here says one oxide, so one oxygen atom. So putting these two things together to make the chemical symbol then, we're going to need the chemical symbol for carbon, which is a capital C. And then we're going to need the chemical symbol for oxygen, which is a capital O. So C, capital O, this is the chemical formula for carbon monoxide. Chemical formula of carbon monoxide. Now, to really see what I'm getting at here, we're going to have to look at a second example. Let's take the example of a compound called carbon dioxide. This time we've got the same elements, carbon and oxygen. But the word here says di. Now, chemists use di to mean two. So what this really means, or what it reads as, is carbon two oxygens. So carbon attached to two oxygens. So underneath, we're going to clarify what we have. We have one carbon atom, one C atom, but we have two oxygen atoms. So for every one carbon atom, there are two oxygen atoms attached. Okay, and this gives us a different formula because it's still C, and there's only one carbon atom, so it's just C. There's no other number here. And we write that there's two oxygens, we write it like this. Capital O for the oxygen, and then just after that letter, we write a little 2 down low here. This here is called a subscript number. Subscript. So a little number down low, we call this a subscript number. And what it does is it tells us how many of the atom that came before that there are in the formula. Let's have a go at another example here. Sodium chloride. Okay, so what I'll get you guys to do is grab your periodic table for me. Okay, grab your periodic table and find the two symbols of these two elements. Do that now, please. Okay, so hopefully what you found out was that sodium is capital Na, like this. So capital Na, all right, because this here is our first element, sodium. And then there's nothing about any number, it just says sodium chloride. So hopefully you figured out that the second element here is chlorine. So that's going to be Na and then a capital C small l. NaCl then is the chemical formula for sodium chloride. That's how you would write it. So what we're going to do is we're going to go to this little table and you guys are going to start doing these in 1 second. I just want to point out for you a couple of things why our chemical formula is so useful. Well, just like the chemical symbols, the way every country uses the same periodic table, if everybody uses the same symbols, then everyone's going to use the same chemical equations as well, the same chemical formula, sorry. So sodium chloride is going to be NaCl in every country, doesn't matter where you go. So that means they're universal, they work in everybody's language, which is good. Okay. It obviously is a shorthand way of writing the name, so you don't have to write the full name every time. And what's really important is that the numbers tell you how many of each atom there are present. So what does this do? It tells us which atoms and how many of each of those atoms there are. So for example, this here in carbon dioxide, in a molecule of carbon dioxide, one piece of carbon dioxide, there was one carbon attached to two oxygen. So it tells us not only which atoms are there, but exactly how many there are as well. That's why it's so useful, it's so important. All right, so what I'm going to get you guys to do is I'm going to get you guys to, sorry, find that screen again. Here. We are going to work just down as far as, we're going to start here, draw a little copy of this table, and we're just going to go down to the bottom of methane here, okay? And there's enough information in all of these examples to figure out what the formula is going to be. For example, we've already done these two. Look, carbon monoxide means one carbon and one oxygen, so that has to be CO. No numbers because it's 1 and 1. CO. Both, notice that they're both capital letters. That's very important. If you wrote it like this, C little o, that will be wrong because this is actually an element called cobalt. This is a different thing completely to capital C, capital O. So you've got, that's why it's so important to use the correct, whether they're capital letters or lowercase letters, very important. Okay, as you can see, the second one is carbon dioxide. This is a very useful column to have here. And I want you to make sure that you do this anywhere where you see it blank. Write down how many, which atoms and how many of each. So one carbon and two oxygens. So we write this like this, CO2. All right, so what I want you to do is do the next three: hydrogen chloride, sodium chloride, and methane. Okay, so you've got the name, you've got how many of each, so you have to write the formula. Pause the video and do those now. All right, so hopefully you have managed to do those okay. There's nothing too difficult here, I don't think, so you guys should have been able to do them. So first of all, we have to think about the symbols. Hydrogen is H, so there's capital H for the hydrogen, and chlorine is capital Cl, like that. So one hydrogen and one chlorine, we simply write it like this: H, there's no number, and then Cl, there's no number. So HCl is the chemical formula for hydrogen chloride. Sodium chloride, we did as an example, hopefully you remember that. Sodium is capital Na, and then chlorine is capital C small l, okay? So again, you always need your periodic table when you're doing these. No one expects you to remember. You'll always have your periodic table, so you don't need to remember everything, all the names or all the symbols. You'll always have it, but it's important that you know how to use it. That's the thing here. So capital N, lowercase a. So there's your sodium. There's only one of them. And then capital C, lowercase l. Again, there's only one of them. Easy. All right, so this is the first one that might have been a test for you. Methane. Methane is made of one carbon attached to 4 hydrogens. So this is the first time I've seen a number that's not a 2. So here you should have said capital C for the carbon, and then H, because it's hydrogens, and then a subscript 4, like that. So this here is the chemical equation or chemical formula for methane, CH4. All right, let's work backwards for a second here. What if somebody gave you this formula, capital Mg, capital O? So capital M, small g, capital O. What does this actually mean here? We have to figure out, what is this formula telling us? Well, first of all, how many elements are there? Well, I see that this here is the first element, Mg. That's just one element because it's capital and then a small. And then O, this here is a second element. So far, I'm learning that there are 2 elements here. Which elements are they? Well, this is the element magnesium. You can go to your periodic table and check. You don't have to remember it. And this here is the element oxygen. So there are 2 elements in here, magnesium and oxygen. Good. Notice the way they are, the order that they're in, magnesium first and then oxygen second. That's going to be important for naming it later. All right, so what else do I know? I'm looking for numbers. I'm not seeing any numbers. There's no subscript numbers. So what does that tell me? There is 1 Mg, 1 magnesium, and 1 oxygen atom. So 1 magnesium for every 1 oxygen atom. That's basically what's going on here. So what I'm going to do is I'm going to go back to this here. And I'm going to work backwards. So I've got my formula, just like we did here. And it says atoms which it contains. So here, we're going to write in together. You do this on the next line. There is 1 magnesium. So just like they did in the row above. And 1 oxygen. So what will the name be then? Well, just like they did up here, look. We always end the name in "-ide", don't we? So all of these were "-ides". So dioxide, chloride. Okay, so this here is a good idea then, that it's going to be magnesium and then oxide, isn't it? So magnesium, ox, and then you drop the "-igen" and you end it in "-ide". We did that last year when we were doing acids and bases and we were doing chemical reactions. So that shouldn't be brand new. Okay, so that should sound familiar. But this bit we haven't done before, working out how many atoms there are and what the formulas are. All right, so what I'm going to do is I'm going to ask you guys to pause the video and do the next 4 now. So from water down to CaO. Pause the video and do those now in the same way that I just did though. Okay, so water was like the ones up above here. Now water has a funny name. It doesn't have "-ide" in it, but water kind of has its own nickname. It would have a proper chemical name, if you like. It would be dihydrogen monoxide. That would be its name if we were to name it. Dihydrogen, 2 hydrogens, monoxide, 1 oxygen. But water has a nickname. We don't really call it that big long name. So water is 2 hydrogens and 1 oxygen. This is what we need to know here to be able to write the formula. Okay, now notice the way that the hydrogens come first here. So hopefully you put hydrogen first here. Okay, now because there are 2 of them, 2 hydrogens, then we must write the 2 after the H like this. H2 and then 1 oxygen. So H2O. This is the correct way of writing oxygen. You may have written it like this, OH2. Like technically that's not terribly wrong, but again, hydrogen just comes first. It is a bit more complicated than this. We will learn at Leave Insert why the hydrogen comes before the oxygen. For now, we'll just take my word for it that whatever I put first here and whatever I put second, that's the order you should put them in. So OH2 isn't really right. And then definitely what's not right is if you did this, HO2. That's definitely not right. If you did that, then you are saying that there are 2 oxygens, because the 2 times the oxygen, and there's only 1 hydrogen, because there's no number there, that means 1. So 2 oxygens and 1 hydrogen. That's not right, because that's not what it says here. Okay, so H2O is how we write that one. So hopefully you got that right. Well done. All right, so on to the next ones, which are more like this one that we did just here. All right, so what do these things tell us? So hopefully we wrote that here there is 1 lithium plus 1 bromine. 1 lithium plus 1 bromine, and that should give you the name lithium bromide. lithium bromide. Okay. Now, if you didn't get that one right, what I want you to do is I want you to pause the video, study what I've done there, and then do the next two again. Okay. If you didn't get that one right, if you got that one right, well done. I'm guessing that you got the next two right as well. But if you didn't, then look what I've done there. We've said one lithium, one bromine. There's no more than, there's just ones there. So we can just name it lithium bromide. You might be thinking, why is it not lithium monobromide? It was carbon monoxide up here. Well, the reason for that is because there's carbon dioxide as well. So you have to distinguish between the two. If we can't just call both of them carbon oxide because they're different things. Okay, whereas this one, it's only lithium, one bromide, there's nothing else. So we don't need to say lithium monobromide. Okay, whereas up here, there's two possibilities. We can have carbon monoxide or carbon dioxide. So in the name, we have to show the difference between the two. Sorry, that's a little bit confusing. Unfortunately, the rules aren't always perfect in these when we're doing chemistry, but they're usually pretty good. All right, so again, make sure you have another go at doing these if you got that one wrong. Okay, so you're only playing now if you're confident you have these right. What have I got? I've got a K and I've got a Cl. So that's one potassium and one chlorine. So the name of this is going to be potassium chloride. Potassium chloride, not monochloride, because there's no other possibility here. It's just potassium chlorine. Next one, CaO. So this would have been one calcium and one oxygen. So the name is going to be calcium oxide. Again, well done if you got all those right. If you said calcium monoxide, again, it's not terribly wrong, but the mon just isn't really necessary here. All right, so the last two are a bit more of a challenge. You're told how many atoms there are, and you have to get a formula and the name. I suggest you start with the two formulas first and then what to the names, okay? So please pause the video now, finish these last two lines, please. Okay, so what you should have said here is we've got two potassiums. So that's going to be K subscript 2 and one oxygen, O, K2O. Well done if you got that right. The name of this substance is potassium oxide. Potassium oxide. Last one, aluminium and oxygen. So it's going to be Al, and there are two of them. So it says two of these aluminiums. So I'm going to write subscript 2 here, Al2. And then there are three oxygens, which means I'm going to write O and a little 3. So here, for the first time, we're seeing that both of the elements have a number after them. So Al2, O3. Okay, and that's possible too. Obviously, these equations or these formulas are a bit more complicated than the earlier ones, but again, they just tell us the same thing. Which elements are present and how many of each atom. So which atoms, how many of each. That's all they do. Easy peasy. Right, the name of this substance then, okay, again, you could have said dialuminium trioxide, something like that, but again, it's the only real possibility, so we're just going to name it aluminium oxide. The name, aluminium oxide. 2 aluminiums, 3 oxygen atoms. All right, so I'm hoping, guys, that you were able to follow along with that chemical formulas. Again, this is a simplified version. They do get a little bit more complicated, but for now, what we've learned there is really good. It's really good ground and it's really good stuff. So a couple more questions for you guys to practice around that now. So questions 164 down to 169. What I want you to do, please, is I want to pause the video and answer them in your copy now, please. Okay, and that's it, guys. We'll talk about those questions, the answers to them in the lesson the next day. Do make sure that you've had a full go at them. Don't give up on them just because they seem a little bit hard. It's very important that you push out and really master that now before we move on. All right, guys, thank you. We'll see you the next day.